Okay, so today let's take a look at finding the expected value of a game. Now, in this situation with the allowance and shooting the free throws for the allowance money, we're just going to find the expected value of the game. We're not really going to answer all the questions on the worksheet. But what we do need to know is what are the outcomes and what are the probabilities of those outcomes. So I've gone ahead and just summarized it a little bit quicker up here for Yvonne's allowance. And let's just take a look at how we go about finding the expected value of Yvonne's allowance. The expected value means over a long period of time, what can she expect to make? So remember that her shot for making was 40% or 0.4. So that's for it to make a shot. So let's go ahead and just list out the outcomes. All right. One of the outcomes is she ends up with $5. Another outcome is that and that's if she misses the first shot, she doesn't get a second shot. Here she makes the first shot, and she gets a chance to get a second shot. Well, if she gets the first shot, she gets the $15, and she would be stuck with the 15 if she missed the second shot. If she makes the second shot, she would end up with $10 more, which is 15 and 10 is $25. Okay, so now, again, remember, if she misses the first shot, she gets $5. So what's the probability of getting the $5? Well, she has to miss the first shot. If her chance to make it is 40%, then her chance to miss it is 60% or 0.6. Okay, so remember, I don't know how else to explain that other than if 40% of her shots she makes it, the other the other part of 100% would be the 60%. So the other 60% would be misses. So she has a 60% chance of missing each shot. So, and she doesn't get another shot. So that would be her probability there. Now, what has to happen for her to make $15? Well, her first shot, she needs to make it. So that's a 40% or 0.4. You don't really need these zeros here, but I'm just showing you where it comes from the 40%. And since I said and, it has to be multiplied. And she has to miss the second shot, which is a 60% chance. And the last one has to be that she has to make both shots. So the 40% has to happen twice. So let's just bring these out. So that's just a 0.6. Now, remember that in expected value, we must multiply all the outcomes times their probabilities of happening and add them all up for probability. So I'm going to add the 0.6 times the 0.5, which equals the let's work these out in a minute here. We got 0.4 and 0.6, which ends up being 0.24. So it's the 0.24 times the this is the 5. That's not a point there. That's the $5 times the $15 and the 0.16. The 0.4 times 0.4 is the 0.16 times the $5. So let's put all these into the calculator real quickly. I'm going to need my glasses for this calculator because the numbers are very small and hard to see. So 0.6 times 5 is 3. 0.24 times 15 is 3.6. Let's do 3.0 just to keep our decimals in there. And a 0.16 times 25 is 4.0. So when you add all that up, we've got a 0.6, bring down the decimal, and what do we have here? 3, 6, 10. So 1060 is her expected value over the long haul for the payout on the game. So if you look at the original problem, and just put this in perspective what this 1060 means, like over the long haul, on average, she's going to be getting 1060 per game. Well, when she started out, if you remember, her dad was paying her $15 a week for her allowance. So if she were to take on this game, on average, she's going to be getting $10 a week, in which case she's losing money. So when her expected value doesn't meet or match up to what she's already getting, she probably shouldn't make that deal. So that's generally how that goes. Now, what you're going to do in the worksheet is you're going to just go ahead, and you can do this at home too if you don't have this worksheet, but you just want some practice. You can keep changing these probabilities that she can make a shot. She could have a 60% free throw level. She could have a 70% free throw level. And if her shot percentage increased, then that is going to change the expected value in the end. So you can go ahead and try that with several different percentages and work them out in the same fashion. So I hope that helps explain the free throw percentages, how to get them, and how to find the expected value for the games. So I hope that helps, and thanks for watching.